Purushottam sir, hope you are here.
Hello.
Purushottam sir.
Yeah, ma'am. Are you able to hear me? Hello.
Sir, are you here?
Hello. Hello. Hello.
Yes, he joined.
Hello.
Purushottam sir.
Yeah, ma'am. Are you able to hear me? Hello.
Okay, sir. Okay, just let's start the session, sir. Oh, again you left.
Hello. Hello. Hello.
Yeah, are you there, sir? But I couldn't hear anything. That's why I didn't see your.
Hi, everyone. Can you please drop a message if you guys are able to hear my voice?
Sir?
Hello, ma'am.
Sir, I made you as presenter. Hope you can able to share your screen also. Just I will give the introduction. After that, you can start, sir.
Yeah, sure, madam.
Yes, sir. You're hello. Okay, sir. Good evening, esteemed resource person and participants. On behalf of the Department of CSE Data Science, MITS deemed to be university, I warmly welcome you all to the day 5 of the AICTE sponsored online faculty development program on smart and sustainable waste management using IoT and data analytics. Today, we are privileged to have two insightful sessions that blend data management and machine learning for advancing sustainable waste systems. Our first session of this evening is on data management for smart waste systems. We are delighted to welcome Mr. Purushottam Reddy, Senior Consultant at Oracle Bangalore. Mr. Purushottam is an accomplished professional with over 7 years of industry experience in front-end engineering, cloud data management, and scalable application development. He has worked extensively in Oracle technologies, data-driven systems, and product design, and is also a certified expert in Oracle Cloud Data Management and Oracle Apex Cloud Development. With his strong expertise in data pipelines, application architecture, and user-centric design, Mr. Purushottam will share his insights into how effective data management practices can enhance the efficiency of smart waste management system. We warmly welcome you, sir, and look forward to your talk. Welcome, sir.
Yeah, thank you very much, ma'am. Thank you for your introduction on my skills and everything.
Sir,
Yeah,
your voice is not audible.
I guess you have some problem with my mic, maybe. So I guess
Sir,
most of the
please
guys
unmute,
able to
sir.
hear me. Ma'am, I guess your machine has some problem.
So maybe.
Hello. Okay, give me 2 minutes. Maybe she's going to join again. Okay, yeah, I guess. Yeah. Okay, please let me know if my screen is visible to you. Just a message over here. Yep, thank you very much. I can see some, sorry. Yep, thank you very much, guys, for joining this session. And good evening to everyone. And today, as ma'am mentioned, it's like we are going to have a session on data management for smart waste system. So this is a FDP session that I'm going to take it now. It's a very pleasure with here with you all today. Okay, and I'm Purushottam Reddy. I'm excited to like explore with you how data can transform the way we can manage the waste in our cities and communities. So, okay, this topic we are going to discuss about the waste management. It's just not about keeping our surroundings clean, but also about using technology and data to make cities healthier and more efficient and more sustainable. Okay, and over the next 90 minutes, we will take a deep dive into data sources and the complete data lifecycle, and also we'll take some real world case studies, which has already been there and which has already been revolutionary change in the cities where like these waste management systems are already been developed, and the future trends that are shaping the next generation of waste management systems. And my goal is to make this session more interactive and insightful. So please feel free to like drop any like your thoughts and experiences as we go along to the session. Okay, and yeah, so this data waste management, so the data management for the smart waste system. So like it's a revolutionary thing, and it's also becoming a backbone of smart waste management systems. And every city struggles with waste management. And imagine if our dustbins like could tell us when to empty them, and when like it's got filled up, and it's like the location, and if they can talk to us. So how like let's say like on how these trucks could find those dustbins in a shortest route automatically. So this all can be made possible only by using the data. Okay, so this is the core thing, and we'll understand the how data flows through this smart waste systems, and the tools and the future opportunities will explore in this session. Okay, and the session objectives here, we're going to talk about understanding the data sources. We'll look at the sensors and citizen inputs and operational data, and everything will going to understand about those things, and master data lifecycle. So how we are going to this data collection actionable insights. So from those insights will how we are going to make it more effective data, to more effective data to manage the best practices, and what kind of tools we are going to use to make it more efficient as a real world examples, you can say, and what kind of real world cases we are going to discuss, like what are the real world cases that has been already using this smart waste management IoT systems, and how the data they are been using to make it more efficient. And we are going to explore the future trends. That means how the AI can take a place to make it the smart waste management system more effective, and the blockchain, and also a gamification thing. And this is like kind of going to be a kind of a practical and interactive session that maybe we can discuss, or maybe you can drop messages on that. So we'll discuss on the points also. If you guys have any topics on, like, any insights or maybe any points to raise. Okay. And so here we are going to discuss, like in this slide, we are going to discuss about the power of data driven waste management. Okay. So like how we can take decisions by using the data. Okay. Instead of like let's say you have a lot of data, that's maybe our raw data, and that is not been segregated into like a kind of a particular in a standard way. Let's say if I consider a Bangalore city, there is like a lot of dustbins being placed at some different places. If you have that data combined together, it's kind of a messy thing, and we need to segregate that data to make it to take any decisions, how we can effectively collect that data or that waste from the dustbins or from the places, and how effectively we can manage the transportation. Okay, that can be done only if you have data that can make our decisions more effective. And resource optimization, so this is going to be like how efficient we can we can collect that waste from the dustbins and from the areas where they've dumped, and how efficient we can manage the budgets. So this all can be done by if you have data. Okay. And after that, predictive management, and how imagine like predicting when the dustbin will overflow and dispatching a truck before it happens. Okay, this is kind of a predictiveness, like once you have the dustbin got filled up, and before spilling the dustbin, like whatever the things that you are going to put in the dustbin, before spilling over on it, we can predict it and we can send a truck before it happens. So that kind of decisions also we can take if we have data. And also the final thing here is citizen experience. So the cleaner streets improve public health and satisfaction scores. So we can improve the service quality also by just having this data wherever like it's been overloaded, or kind of like it's been need to be cleaned on time. So these kind of things we can make it happen if we have data, and we can make that areas and the society more cleanliness for happiness, for happier communities. Okay. So here we can discuss the waste management and the critical challenges what we are facing in urban areas, and most of the places where the cities and wherever it exists, where the population growth is very high, and there is like a lot of critical challenges we are facing it here. So first, we'll go with population growth pressure. Okay. So as we can see, like cities nowadays, cities are like overwhelmed with the population. That is mean like everybody is actually coming to this single centric place and occupying the places, and they like we don't have any proper management for the collection of waste and dumping the things and everything. So because of this, we are like having some critical challenges. That is like, like in an urban India generates 1.5 lakh tons of solid waste daily. So if we have this much huge like waste that can't be managed on proper daily basis or in a proper way, that's going to make the societies like a waste, we are going to live with the waste. So that's going to like a very the worst situations scenarios we wanted to avoid. So this is the one critical challenge, that the population growth is very high in the urban areas. And one more is inefficient collection. So as I mentioned, so we don't have any proper collection systems existed, even though we have like the trucks and the so the people from the municipal areas, they're been spending their time to collect these things and dumping in one area, but still there are some gaps that we need to plan, and we need to fill those service gaps. So those gaps means like maybe the route what the trucks guys choose to pick up the dumps, pick up the bins. Okay, so this is like kind of, we can more make it more efficient by just this is also one critical challenge we can see. And here it's like uh, let's say, if we take Bangalore as an example. So here anywhere if you see like it's like congested with a very most of the traffic areas. So it's like overwhelmed road droppings. And if we have proper collection of locations and the paths and everything, if we make it more efficient by using the data, we can make it more optimized by saving most of the time. And we can make it more planned way of collecting the waste management. Okay, and one more is public health concern. So there's overflowing bins and poor waste management of handling create hygiene issues that threaten actually a community health. So here like it's because of where like if the municipality guys are like the whoever going to collect the waste, if they are not on time, and if they are not collecting for some days or maybe months, like it's going to be like there settled as there. And it because of that the hygiene issues are going to come up, and the health issues is going to rise. And this is also one critical challenge that public health actually concerns about. And financial burden. So this is actually, budgets are tight in the cities to collect the things and to make more trucks to be in place to collect the collect the waste and everything. So and also it's like it's rising operational costs, and municipal budgets are very limited to the standards. So because of that, it's also going to be a very critical challenge that needs to be taken care by just having the data that can be possible. Okay, and also the main thing is citizen engagement gaps. Okay, so most of the citizens like won't take care about like how will manage the waste. And they won't care about like they won't care about most of the guys, like they don't have that much issues, maybe because of they're dumping the waste at anywhere, and they're just mixing up all the things. And it's very very critical to separate the things from the collected waste management. So let's say we have like a dry waste and wet waste, something like that. So if we can create the awareness in the citizens and in the society to make it more segregated way of collecting dumping the waste, so that would be really easy. And that could like that will take the municipal collection, the municipal trucks also, and the guys also can collect the waste very easily without like making them more work to make the separate things to separate the things from the waste they have collected. And also the recycling is also one of the thing that citizens should take care before they're dumping into the bins. So these are the most challenges, critical challenges, uh, because of we even though we don't have much of the collection of data. So these are the most critical challenges in the urban waste management. And here we are going to discuss about the key stakeholders in the smart waste ecosystem. Okay, so this is like we are going to include the main participants and stakeholders in this ecosystem. That is the first thing is citizens. So this is the first link in chain, because from there the management the waste is going to be generated. So this is the first step that we need to take care for source segregation and and provide feedback and adopting the sustainable practices. So if citizens have raised these concerns and if they make the segregation of waste and everything is they made it as an initial step, then the remaining things is going in a flow. They can easily the remaining flow is going to easily adapt to the collection of this this waste. Okay, and the second thing is municipal bodies. This is actually overseeing collection operations and transportation, logistic and service coordination needs to be more more kind of active in the municipal bodies. So they need to plan and allocate resources and monitor the performance. Then they can easily track the data and everything that can be easily maintainable the waste management. And one more is private contractors. So often will handle this specialized recycling or processing the things, and this is going to make more value from the recovery from the waste streams. They can nowadays we can see most of the private sectors are like spending their money to the renewable energy things. So they'll connect the waste and they'll create they take all the waste to their factories and they are creating some renewable energy from the waste. So we can just give this waste to the private contractors and they can make use of it to create the generate renewable energies. So this is also going to one of the most uh, important stakeholder in the waste management ecosystem. And government agencies. So why agencies need to develop our regulatory frameworks, and they need to provide fundings and ensure the compliance with environmental standards. So the environmental standards means they have to maintain what kind of waste they need to dump and what kind of waste they can use for the to create the renewable energies. And these kind of things they have to initiate, and government agencies also can provide funding to make this waste management the workflows and everything. They can make it more powerful by funding them by funding to the private contractors or maybe to the citizens, and they can provide the regulations how they can handle it. Okay, so when all the stakeholders work, so when sorry, this one more thing is the technology providers. Technology providers is actually nothing but when we work with any IoT or AI systems, so we need to choose them wisely, and we can, because it's kind of again going to be have some we need to spend some money on it to get these things comes into the society, and that going to be also we need to think about the how what kind of technologies we can use and how efficient we can use them to make it smart waste ecosystem more powerful. Okay, and when all these stakeholders work together, we can see results like the cities which are already been using the smart waste ecosystem efficiently. Okay, and data types powering smart waste systems. So here we are going to discuss about like what kind of data types that we are going to get, and from where what type of technology we are going to use it to get it the data. Okay, so first thing is the sensor data. So this can give us a real-time monitoring of fill levels and also the temperature variations and also the weight measurements for smart bins. So real-time monitoring is actually going to very really helpful when the dustbins are going to fill, so they are about to fill, so they can get some give some signals to the provider, maybe the municipality workers, so they can directly come to the bin and they can collect the dump, they can collect the waste. And also the temperature variations. So if it is like kind of a mix of wet and dry waste, so if there is any temperature variations happening in that, so sometimes the dustbins gone explode because of some over temperature, and they might filled up, and there is no space of like the whatever the waste they have been dumped in that, so that might be get some severe reactions inside of it. And also it's kind of like maybe it can cause some blasts also. And also the weight measurements. So if some of the dumps have really like heavy loaded, so because of that, the municipality workers also can't like fill their trucks with the heavy loaded bins. So that is also one kind of thing that we can easily maintain by just inserting a sensor to the bins. And location intelligence. So here we can add GPS trackers to optimize the routes. How like let's say like the truck drivers are like actually roaming around the city, and to just collect the waste, they have like taken a longer path, and that might be costs that again going to cost and burden on the municipality collector uh, the funds fundings only. So we can optimize the routes to how efficiently they can collect the dusts from different areas. We can optimize it by just dynamically optimize the different locations, and also they can collect the critical zones. Maybe some of the zones really get the waste get really filled up in the dustbins. So for those specific routes, they can go very quickly and they can collect it, and they can visit those kind of areas frequently to collect the data. So these kind of things we can optimize by using the location intelligence. And citizen interactions. So in the citizens interactions, we need to think on how we can get the feedback or any things from the citizens directly. Okay, there are like so many third party waste collectors are there in so many urban areas also. They have like mobile applications and also some dashboards, and also they can citizens can directly order through mobile apps or online to pick up their waste. So these kind of things we can come up, and these kind of things we will collect the data to make the waste smart waste system more efficient way. Okay, and also the operational data. So here we're going to like this operational data is nothing but like we can use what kind of manpower we're going to use, and the truck schedules, and also we can schedule the things which includes the operational costs. This can everything can be scheduled from single place, and they can easily manage them, and that can power up the smart waste systems. And finally, this recovery analytics. So this can track how much is recycled and diverted from landfills. So this is also more important, so that we can this is also one more important data type that uh, we can make it as pivot section in the smart waste systems. And these all types are really important to get a complete picture of smart waste ecosystem. Okay, and coming to this, we are like I guess I hope this IoT architecture is already been explained by some of the guys, but here we'll go to this architecture again. So this is how we are going to build a smart infrastructure by using the IoT system. So this is how the physical bins can directly talk to digital systems. Okay, the first layer is smart sensor layer. So this is like, as I mentioned already, so we'll use a sensor into the bin that can be attached. And here we can use ultrasonic or weight sensors that can detect the fill levels and and the weights. And also we can use the temperature sensor to get to know the temperature data of the bin. Okay, so this is one layer we can will go ahead, and the next layer is going to be communication networks. So how we can communicate from this bin to a real life, the real data digital ecosystem. Okay, we can use any WAN networks or maybe MQTT protocols to ensure the reliable and low power data transmission to cloud platforms. So this is a more efficient way we can connect with our dustbins, like our bins to the digital platforms to collect the data. And one more is the scalable storage. So we need to store these collected data somewhere, right? So this is where we can make use of cloud-based database providers. And why I'm recommending this is like it's going to be like secured and scalable storage for massive volumes of operational data. So we can make use of some SQL or no SQL packages to just store and create the databases, and we can provide a secured and scalable infrastructure for them. And here analytics layer. So this analytics layer, we can use machine learning or AI or BI dashboards to advance the the processing engines to transform the raw data into actionable insights. And also that can be used for the decision makings. Okay, and the data management, so the dashboard managements. So these can be managed by the municipal workers, or maybe if it goes for the private sectors, they can manage also. So these dashboards are actually going to give you a really insightful information, and they can interact the visualization tools to make it more operational comprehensive oversight. Okay, so this is actually a real-time loop that going to make IoT architecture very strong by just collecting the data by using the sensor and sending the data to the cloud. And there from there we can get the intelligent analytics by using the decision, by using the some tools, BI dashboards and machine learning tools to make it decision, and we can perform the actionable insights from the dashboard. Okay, and here we're going to discuss about end-to-end data pipeline architecture. So how we can like going to take these data pipelines end to end to make it more robust way of having the complete smart waste ecosystem. So the first one is the data collection. So here we can use the sensors and apps and operational logs. So sensors is going to just send the data, and mobile applications also. If we provide mobile application access to the citizens, they can directly add the information about the waste around surrounding them, or they can give the inputs, and we can collect the data from that mobile apps also. And also the operational systems. So that is also we can from there also we can collect the data. And the second one is ingestion ingestion of data. So that here we need to maintain the data in a robust way, that all applications and all the systems need to be aware of the seamless integration of aware of the data flow. Okay, so here we are going to use Apache Kafka streams and RESTful APIs. So this is actually going to, like, let's say somewhere you collected some data and that needs to be like reflect in the system. So we can make use of this Kafka or API tools to make it happen on the real-time updates in the applications or maybe in the systems, so that everybody aware of the things. So this is going to be like more real-time real-time data ingestion. And also The third point is secure storage. So we need to be very really careful about the data leaks on for the scalability. So that means like if there is any kind of some like uh, unsecured a platform if you build. So if someone comes to the system and they make some kind of hacks on top of the system, so we don't get the real-time data and it will affect the entire ecosystem. So that is also going to be cause the entire smart waste system flow into a danger thing. So that's the reason why like we need to maintain the data for in a secure way for the scalability as well as for the data leaks. Okay, and the fourth point is processing the data. So how we can process the data in a cleaner way so that this data can be used for the remaining, maybe for the analytics purpose or maybe for some other purposes. Maybe some volunteers can come up and they can have this data and they can come up with a more kind of uh, more thoughtful way to make it more efficient. So for that purpose, we need to make it more cleaner. Whatever the data we have collected, we need to make it more cleaner. So that means like, let's say we have a waste, different waste types. So if we make it segregated like wet waste, dry waste, and plastic waste or iron waste, something like that. So this is how we can clean up the data, and this can be more useful for the analytics purpose also. And the fifth point is advanced analytics systems. So this is going to provide more insights by taking this data from the smart waste systems, and this give more intelligent dashboards and machine learning models also we can generate by using this more the segregated data. So machine learning models, I mean to say like, so if we teach them with some feedings of initial datas, so if we like wanted to make system more robust and more efficient, we can take help from the machine learning and we can make it more efficient by just providing the this data to the those machine learning models. And the final point is operational action. So this operational action also we can so here we can optimize the routes where the truck drivers can easily reach the dustbins whichever is got filled up, and also the predictive alerts means if the sensors in the dustbins got triggered an alert, and or maybe if they are about to reach, by using the sensor we can get the alerts. And also if there are any areas that is been quickly filled up, so we can get the insights from the dashboards, the business intelligence dashboards. We can get the insights and we can predict, okay, this area might be like get the dustbins really quickly filled up. So that kind of alerts also we can give. And also we can perform the recommendations to drive the results. That means like overall the infrastructure we can optimize it by using this end-to-end data pipeline architecture. And in this also, if any step fails, the entire system output is going to be affect. If we are not getting the data collection data, if there is any fails or data ingestion, we don't get any real-time updates. And if the data is also not not securely stored, that is also a kind of a failure in this pipeline. And processing the data, if there is any failures in processing the data, that is also a big failure. Then they don't get any proper data, that is also kind of like again making the data raw data, and taking the raw data to the system is going to be very difficult to understand by the systems also. So this is why like every step in this entire pipeline architecture is going to be very crucial. If there one is fails, the entire ecosystem is also going to be affected. And we're going to discuss about what is the comprehensive data collection in this step one, the first step. Okay, this here we are going to get the data from multi-channel data sources. Okay, as I said, First is going to be IoT sensor networks. So that's where been fitted to the smart bins. We can that will be equipped with the ultrasonic sensors and live GPS trackers, provide for the real-time vehicle positioning for the trucks. So this can be this is also one data source that will we are expecting data, and one more is manual data entry. So that means, as I mentioned, like if we give access to the citizens or maybe some the municipal workers, they can directly add enter the data about the waste and everything from the through any middleware, that may be a mobile application. Okay, this can enable the citizens to input observations and complaints and maybe any requests that they can raise directly. And this is also one more main important collection of data. And one more is the quality assurance. So this is being used for like robust validation protocols to ensure the data accuracy and consistency, and optional collection of frequency for reliable insights. So this is also one major data source that we can take it up from the quality assurance portal. Okay, and here the critical success factor is, so it the data, whatever the data we are going to collect, so this is directly impacts the system effectiveness. So if it is in organized and well maintained way, so that's going to be like very seamless to ingest into any data management systems. Otherwise it's going to be like directly impact the effectiveness. So that's why we need to validate the checks and the calibration of the schedules by using this quality assurance. Okay, and the step two is secured and efficient data transmission. So how can we encrypt and we can process the data, okay, to make the secured connection established for this entire ecosystem. So first thing is the security first protocol. So we can use, if we are going to use any online portals, so we need to make them as more secured. So for the websites we can use HTTPS protocols to ensure encrypted and authenticated data transmission, protecting sensitive operational information. So let's say if we have like provide any dashboards or any websites that they can any private sectors or maybe any municipal workers can use. And if there is any, like if it is not secured, and if it is like open to anybody access, open to anyone, and if they accessed and they dumped some random things, and that kind of things gonna break the connections and the data transmission between the entire ecosystem flow. So this is the first step we need to be very keen on. And one more is low power networks. So this is what the bins, the IoT sensors can make it more efficient. And this technology is actually long range and energy efficient communication for extended sensor life cycles. So this is going to be really helpful to make the network more established way. And the edge processing, the intelligent edge computing is actually going to reduce this require bandwidth requirements while enabling this real-time decision making. Okay, this is actually going to be an more one more efficient and secured way, that this edge computing is actually going to make this bandwidth and bandwidth requirements in an affordable way. Okay, so here like effective data transmission forms the backbone of the entire ecosystem of waste management. And this is actually going to connect the physical infrastructure with the digital intelligence. So this secured and efficient of data transmission is going to be like it's going to very keen a very need to be very secured, and need to be edge processing for entire next processes in the smart waste management ecosystem. And the step three, here we are going to building the data storage foundations. Okay, so this is actually going to be uh, this is a maybe here we are going to use the entire ecosystem to make it more effective by using the robust data infrastructure. Let's say we maybe opt with the cloud based or on-site on-premises infrastructure. And here, like nowadays, like on-premises infrastructure is also going to be like very difficult to maintain, and the things is also going to be like very difficult to shift the data centers to one place to one place. So most of the like this next generation is going to be happen on cloud-based storage solutions. So this is going to like easily provide the scalability, maybe with some extra costs, but it's going to be like affordable way of scaling the storage for for our entire ecosystem. So this is used and needed for the continuous data streams for from the IoT sensors and the smart bins, and also the GPS trackers which we are going to fit for the trucks and also the municipal workers. Okay, and here the first thing is cloud data sets. So that is sorry, the cloud databases. So that is here we can use any database SQL to create data for the structured transaction data, and NoSQL for the flexible sensor data formats and real-time updates. So we can use these two cloud database structures to make it more efficient way of building the foundations for to store the data. And one more is data lakes. So here we can use this data lakes to store the vast amounts of unstructured data from the multiple sources. So that might be our GPS coordinators or like sensor logs, or maybe the images from the mobile applications, or maybe from the customer, the citizens or municipal workers. So these things need to be like these are the more unstructured data, right? So we can use the data lakes to make this happen or to in a uh, robust way. And whatever the data system that we are going to build, that needs to be highly available so that the entire ecosystem can like easily make the next steps happen, and the insights and everything we can get it from the storage data storage. That's going to be like very easy to make it happen, and this needs to be very high available. Then only we can implement the redundancy and backup systems to make it more high availability of entire ecosystem. And this is actually to ensure the 24 by system operation and prevent the data loss. Okay, and here the step 4, we need to be a more focus on that the data processing, that is from raw data to the ready actionable insights data. So this means like we need to like more keen on the transforming of raw sensors data, not only a sensors data, maybe it's kind of like or images or maybe the GPSs and everything. So into this entire data into actionable insights through our systematic process workflow. So we need to process this entire data, this raw data to make it ready for actionable insights. Okay, and here the first thing is how we can make this happen is by using the ATL pipelines. And this ETL pipelines we'll discuss like one by one. So first is extract, and the extract means we are going to pull the data from the IoT sensors and the legacy systems across all collection points. We have will try to get as possible as from the different collection points, so that we have like most of the data collected, and we need to extract it first, and we need to transform the data. So we need to transform the data means, so if there is any kind of duplicated data is being generated, and maybe if there is any missing data happen, and if there is any kind of quality rules that may be violate the accuracy of data. So we need to do all those transforms in this second step. And the last step is load. So we need to standardize the units and the formats of data, how what kind of formats we're going to expect, and what kind of data formats that we're going to push to the data storage, and the timestamps before loading into the central data warehouse. So we need to be aware of, and we need to be make this happen before we are going to push this entire data to the central data warehouse, that means the cloud. Okay, so this entire ETL process typically handles the like millions of data points daily. So this can be happen in the smart city waste system management. Okay, and the step 5, data analysis. So here we are going to discuss about the 3 high level of insights. Okay, so that can be transform or process the data into the actionable intelligence through the progressive analytical approach. Okay, so the first one is descriptive analytics. So descriptive analytics means like what happened. That means the historical analysis of the fill rate of bins, and the waste reduction, and the recycling rate. So and also the operational performance metrics. So this can be used for the descriptive analytics, and here we can get the historical analysis of the already processed data, and we can collect the patterns. If we collect the patterns of how the truck is traveling through the city to collect the bins, so we can analyze it, and we can make it more efficient way to make it happen in within operational budgets. And he can the trucks also can reach the bins in a easiest paths. And the second one is predictive analytics. So what will happen? That means like when we have the data, a lots of data in this, and we can make the predictive, we can predict the bins when they are going to fill up to the levels. And also we can anticipate the seasonal demands. Let's say if some festival seasons are going to happen, if we have like years of data already, and we can analyze it. Okay, this kind of seasons, the bins and the waste is going to be heavily dumped in these areas, particular areas. So they can take the actionable actions before it's going to be happen. By just having this data, they can take the actionable metrics in future things also. So this is one level of insight that will actually considerable in the smart waste ecosystem. And this last analytics is a perspective of prescriptive analytics. So this is what should we do. So if we have this data, we can optimize the up collection routes, and also we can recommend the resource allocation. As I said, like if there is any kind of areas, depends on the season, maybe if the waste is going to be really huge, so we can increase the resources in that particular areas, and we can make the the waste collection more efficient way, just by using this historical data. And we can also suggest the policy interventions for making this the entire waste management collection. So this entire analysis is it's going to be like very useful. uh, this entire analysis is going to be done if we once we have the data. Okay, and the last step is data sharing, and it's actually democratizing the information. So it here, like if we go with this of data collection and everything we have stored, and we can create a dashboards. Okay, that can be managed by any municipal workers, or maybe managers or private sectors, or maybe we can give this data to the open platforms. Okay, that can be used by anyone, and this is kind of like a open APIs for, maybe they can use it for the research purpose, or maybe for the future developments of purpose also. So this data sharing also need to be more a proper way that we need to maintain. That is like role-based dashboards. So here, like we can create the dashboards by using the data, and that can be only we can limit the we can limit the data who can see that. Maybe if we wanted to, there is any some crucial data about the waste management, maybe some financial things, we can limit them to the role-based access. And also this is used for the actionable insights and relevant KPIs. Okay, and this can be limited to managers or field teams or executives. Okay, and one more is the public transparency. So here, as I mentioned, we can like provide the data to the citizen facing portals, maybe the government portals. They can, we can display all these collected data as per the schedules. And also this can be used for the service quality metrics, and this can be used by the public. What is the environmental impact that this data, entire data is actually made. And one more is this is the open APIs. As I said, like we can also push this data to the open APIs. So this can be used for the by the researchers, or maybe the startups, or maybe any guy like who is actually make this data more innovation and analysis purpose. They can also use this data. Okay, so and this effective data sharing actually builds the trust in the society and the citizens, while fostering the innovation through this partnership and the research and research communities also. Okay, and we are going to discuss about this essential tools and technologies which we are going to use it for the modern waste management. Okay, here this as we are talking about the modern waste management system, so we have to like leverage the most advanced cloud native technologies for the for the scalability and real-time processing, and also comprehensive data visualization. So the first we are going to talk about the databases. Here we can use the most popular database structures, that is a PostgreSQL or MongoDB for flexible schemes. And also there is one more global distributor that is Azure Cosmos DB. So these are the biggest players, and also mostly used by the society, the advanced technology we can say. So this can be used to make the databases. And also for the streaming purpose, we can use Apache Kafka and Azure Event Hub. So this can handle high velocity sensor data systems for the from thousands of collection points. So this Kafka and Event Hub is actually going to make more a crucial part in sending the data to the databases from the sources. So these are being used for the real-time data transformation, the Kafka and Azure Event Hub. And also we can use the AWS SQs also. So that is also going to trigger the data live streaming. And for the processing data, we can use Spark for big data and Databricks for ML. So this can be these two things also can be used for data processing, and there are multiple tools, but as per my recommendation, we can go with these tools for the data processing and data visualization. So more we can use Power BI, and there is one more tool, Grafana, for decision making dashboards. To implement these dashboards, we can make use of these tools. Okay, for this is the suggest open source options. So for smaller cities, our open source tools can reduce the costs because these are the like very open sourced ones, what are the technologies I've suggested. So we can take these tech stack to make it more efficient way of and building the entire modern waste management systems and overcoming implementation challenges. So what kind of challenges we are going to get with this smart waste management system implementations that face significant technical and organizational hurdles that require the planning and the systematic solution. Okay, so here we are going to discuss about the first solution, that is break soil silos, that is the data silos. So the departments operate isolated systems and that preventing holistic view of operations and limiting cross-functional insights. So this is one overcoming implementation challenges we need to be go with. And the second one is, sorry, volume and velocity. So here how we can manage the massive data streams from thousands of sensors requires actually a robust infrastructure and also the real-time processing capabilities. So that is also need to be like taken care, because in future maybe we have like a lots of volume and there is a bulk velocity of having of processing the data. There is like a lacks of dustbins being placed in the cities, that we need to get our real-time live data without loss of any data transmission to the sources. And the third one is hardware reliability. So here we need to be we have these challenges on sensor failures and maybe sometimes inaccurate readings. So these are the machines, right? So they might get sometimes they might fail and there might be some inaccurate readings that happens. And because of those things, we need to compromise the data quality, and this is going to be like requiring the redundant system and quality monitoring. So for this hardware reliability, as I mentioned, like we need to like more focused on the quality monitoring, and we need to be aware of the redundant system of checks to make this to make this hardware reliability mostly on up and high. And the fourth one is security and privacy. So here this we need to protect the sensitive citizen data while maintaining the system accessibility demands and also the comprehensive cyber security frameworks. So here like once we made this smart waste ecosystem build happen, and we need to maintain the privacy of whoever registered through to these environment through these applications. Maybe some citizen data we might collect, and this kind of sensitive data we need to protect, and that for this we need to maintain like more comprehensive cybersecurity frameworks to make this happen. And the budget constraints. So this is like the major problem we can see, that limited municipal budgets. Uh, this is actually kind of a challenge to make the technology adoption. So this requiring phased implementation and clear return on investment demonstrations to make this budget constraints or challenging. Okay, so these are the phased implementations to minimize the risk, as we can observe in entire smart waste ecosystem. And here we're going to check the we'll look at the solutions and the best practices. So the first one is the cloud native architecture. So this implements a scalable and elastic infrastructure that actually grows along with the data demands, and it's actually ensure the high availability. So that is why like instead of making it on premises, if you go with a cloud native architecture, so we on demand, if we have like data, if we are going to get huge data in future, so we don't need to again run for data setup and everything. We can make use of the cloud native architecture to make it happen easily. So this is a kind of like easy, the best practice I've recommend. Okay, and data governance. So data governance, here we're going to establish the quality checks and validation rules and standardized process to maintain the data integrity. So here we need to maintain what kind of data that needs to be flown into the source, and like we can validate that, we can put some rules to validate it, and we can standardize the process, like in what process. So it has to reach the source. We need to set up some process that can maintain the data integrity and real-time monitoring. So here we need to deploy automated alerts and anomaly detection to identify issues before they impact operations. So we need to monitor each and every part in entire ecosystem, in smart waste ecosystem. So that can be like alert, that can give us the alerts, or if there is any kind of violations or maybe data breaches or anything happen, so that will trigger real-time alerts, so we can quickly take a look on it and we can resolve those things. So that's why we need to maintain a real-time monitoring of things. Okay, and end-to-end encryption. So again, here we need to again the security protocols comes into the picture to access, to give uh, here we are going to collect a huge data, right? So we need to maintain it as secured as possible, because if there is any data manipulations or data breaches happen, then the entire system will collapse, because the data is mainly a core backbone part in this smart waste ecosystem. So that's why we need to do end-to-end encryption for the to secure the data. And here, like the stakeholder man engagement, so this is also one solution best practice I can see, that we need to train the staff comprehensively, and also we need to engage the citizens through some education programs or maybe some feedback mechanisms, or maybe some digital awareness. So we need to make sure that everybody should aware of this entire ecosystem, so that they can make them use very efficient in efficient manner. Okay, and here I just wanted to mention about a success story of smart waste management system, that is Barcelona city. So in this Barcelona city, so this is like they already like made this possible by using this smart waste management system. That is actually, this demonstrates the tangible benefits of data driven operations, and also this is a citizen centric technology implementation. Okay, we can also kind of like we can also make use of that entire ecosystem, and maybe we can do some growth hacking to make that happen in India also. So this, so they are already experienced these metrics, the Barcelona's transformation. So this is the transformation they have like already experienced, and that is already in the place. That is, the cost reduction is already happened 10 to 15% through the optimized collection routes and resource allocation. So if we see it in this 10 to 15% in a bigger picture, so this is a major step that has been happened in this smart waste ecosystem, the management ecosystem. Okay, and also there are like 7,000 plus smart bins they've already deployed. Okay, they already deployed in this entire city, and they are actually monitored in the real-time metrics. So this is actually one more a big achievement they can we can say. So, and also this is how we can enable the entire city a more advanced and smartest way to collect the waste management. And once Yep. And this there is a 25% route efficiency that is being improved, and route the collection route optimization using this data driven algorithms. So as I mentioned, like if we have data, we can we can act on top of the data, and we can predict in, and we can optimize the entire ecosystem by just taking some steps on like optimizing the route, and collecting the real-time metrics of from the smart bins, or from the dumped areas. So this in just like in just 6 years, they ranked like sorry in India also there is a city Indore, so that is actually ranked within a 6 years cleanest city. In Indore also there is this is already happened. So here like we're going to discuss about this success story about the Indian smart city. Okay, this is like ambitious. So India's ambitious smart cities mission, and showcases it showcases innovative approaches to waste management, and through the technology integration and citizen participation platforms. Okay, so here it's actually have like a live GPS trackers for the tax. So that's how they maintain this happened in India also. So the first initiative that come with Swachh Bharat dashboards. So the national mission tracking cleanliness and metrics of waste collection performance across the cities. Okay, this is the one mission that is India already initiated, and also one more is the indoors real-time tracking. So as I mentioned, like indoor have a real-time GPS enabled waste trucks with route optimizations, and reducing the collection time by 30%. 30% is not a like a small one, so it's a big achievement they made by just have these route optimizations to reach the dustbins and the smart bins. Okay, and one more is the citizen grievance apps. So they've introduced, India is introduced like a lot of grievance apps that citizens can access through the integrated platforms, allowing residents to report issues and track resolution status. And this is actually consistently ranked, this Indore is actually consistently ranked India's cleanest city for 6 consecutive years. So this is actually really, this happened because of this IoT waste management systems. Okay, and here we are going to discuss about the future of smart waste management. Okay, so what kind of like the smart waste management system that's we're predicting in the future by using by using all this existed the technology and the systems that we can incorporate to make this more futuristic and modern way. So here we're going to use this emerging technologies, a promise to revolutionize this waste management through automation, transparency, and citizen engagement innovations. Okay, so here the first step is going to be AI. So this is emerging technology, and the most happening technology in the entire world, that is AI driven prediction. So here we can use machine learning algorithms to predict optimal collection times, and also reducing unnecessary trips and emissions. So we are using trucks to collect the uh, waste, right? So if he is like not aware of if the trucks are not in a right way to collect the dustbins in a if they are not in a optimized route, and they are going to like use the most like the petrols or diesels. So it's also kind of like because of more are not in optimized way. So they are like silently they are a part of the pollution creation. silently. So this is also we can predict through the AI driven approaches, and we can reduce these trips and emissions, and will make this happen by using this optimized collection timings and routes. Okay, and the second one is robotic sorting. So this is again a safety plus higher recycling efficiency. So this advanced robotics, as I mentioned, like with the computer vision, will automate the waste sorting, and also it will improve the recycling rates and worker safety. So if we are going to use the machines to make the work, so that will the accuracy also going to be very high, and also we can improve the recycling rates, and will also ensure the worker safety. So this can be happen by using this robotic machine involvements in the future smart waste management. Okay. And the third one is actually a blockchain traceability. So this is actually going to distribute the ledgers will track waste from the generation to disposal, and it's also ensure the transparency and compliance. So as I mentioned, like if we are going to maintain this entire data, so we need to like use some kind of blockchain technology to make this more compliance and traceability way, to make sure ensure the entire data is more secured, and that can be distributed along with this from the generation to the disposal, the entire process. And the fourth one is gamification. So this is like a kind of a future that everybody is like looking, and we can make the citizens, mostly we can reward the citizens for proper segregation. So like let's say if we have like different waste types at home, so if we make it more kind of a gamification, they can citizens can engage through the platforms, and they can also get the rewards, and they can also we can also make some competitions to engage and encourage the proper waste segregation through these gamification kind of models in the future. So these are the areas where the academic research can make a huge impact. So it's like the research is actually the academic research is going to be like uh, more need to be more innovative in the future to make this happen in all these four recommend in the four future steps, in the AI, or maybe the robotic sorting, or in the blockchain, or gamification. Maybe in future we can add a few more visionary points to make this a smart waste system more efficient way to make this happen. Okay, and this the convergence of these technologies will create truly a sustainable and citizen-centric and waste management ecosystem, and also we can make truly intelligent waste management ecosystems. Okay, and smart waste management data-driven solution. Here we are going to recap the main points here. So that is data driven foundation. That means the data collection here, that's real-time data collection from the from it's going to be like going to be a backbone of entire ecosystem, that's going to be like enabling the predictive analytics and intelligent waste management waste systems, and also we can make the efficient way of collecting the waste by optimizing the routes. Okay, and the second one is the technology integration. Again here, as it's like cloud computing and IoT sensors, and like the algorithms, machine learning algorithms, these all together can work and to create a seamless and scalable waste management ecosystem for modern cities like Bangalore, Mumbai, Delhi, and also these are the mostly more populated cities, and these are here like data waste management is not in a way that they can easily maintain and easily track the things and everything. So here if we go with the more advanced technology integrations, so we can easily achieve these kind of entire ecosystems and that can make a really more real impact in the society. And here one more thing is the cost and the service optimization. So here we can go with the strategic approaches by just taking the data management reduces the operational costs. So as we can, let's say about like 25 to 40% while improving the service quality through the dynamic scheduling and resource allocation. So this can be happen maybe up more than 50% also by if we are going to make the data real use. That means like we can take the strategic approaches and strategic innovations and plans, so we can easily reduce the entire costs, maybe go more than 50% also. And the other thing is multi-stakeholder success. So here we can engage the citizens to make this entire ecosystem works in an efficient way. So because citizens are the roots of this and this entire ecosystem. So we first need to involve and prioritize the citizens to working towards the shared sustainability goals. And also for that purpose we need to use entire the technology providers and municipal governments. We need to collaborate with all these stakeholders to make this entire ecosystem more successful as a citizen centric point. Okay. And the implementation impact. So here if we are going to make this smart waste management system successful, so there are like cities implementing this smart waste system reporting a significant improvements in operational efficiency and the satisfaction of society and the environmental outcomes in the scenarios of collecting the waste and creating renewable energies on top of it. And the key straight starting the key is a starting with the pilot programs that demonstrate a clear return of investment before scaling citywide. So these pilot programs is nothing but we can make some initiatives of making the creating the awareness of smart waste ecosystem. And also we need to like give some um, the kind of educational inputs to the students or maybe the childrens and so and also the citizens whoever living in the society, so we can guide them to make this happen and we can this is going to create a real impact, just being aware of the environment outcomes. Okay, so this is just think about how like the department and the department can research and prototype or pilot solutions. So this is kind of like a like we can action trigger point, we can make it this entire ecosystem going to be happen. Okay, so yeah, so this is about the like the data driven solutions and the data importance of the data in smart waste management. And like if so this is kind of like a collaboration between the academia and industry and government is key to create this entire network. Okay, so this maybe there might be some problems in their municipalities and the technologies they have explored, and maybe we can come up with all these problems and so we can create some pilot projects by using these ideas. And we can make this smart waste ecosystem management that's going to be like really effective in the society that can take real impact of clean India and make green India. Okay, so yeah, guys, this is about the session, and do you have any questions and answers, and maybe if there is any points that we wanted to discuss, so we can go ahead and we can discuss about them.
Participants, mic is enabled for you. If you have any questions, you can ask now. Hopefully, that is you have explained everything. That means the challenges, solutions, and everything you have explained. So hopefully, they don't have a question. I think so. So if there is no question, we can conclude this session. Uh, Thank you,
Yep.
sir. On behalf of this organizing committee, I extend our sincere thanks to Mr. Purushottam Reddy, Senior Consultant at Oracle Bangalore, for delivering such an insightful session on data management for smart place systems. Your talk highlighted the crucial role of data management in smart waste systems and gave us practical guidance on the essential tools and technologies also, whatever used in this domain. You have explained how to overcome the challenges in managing large scale waste data and backed up with success stories also and with the real world applications, whatever we have used, we are currently using, which made the session very engaging and relatable. The clarity of your explanation also will certainly help our participants in exploring both research and implementation in this area. We sincerely appreciate your time and effort in sharing your expertise with us, sir. Thanks
Yeah.
a lot for the wonderful session, sir. Thank you so much.
Yeah, thank you very much for having such a great session today. And yeah, I'm also I encourage all you to take these insights back to your maybe institutions and cities to explore and research some kind of pilot projects to collaborate by collaborating with the technology providers, and maybe we can involve students in researching these issues by just having some real world challenges. We can address these challenges. So we can work together to build this more sustainable and smarter waste management system to serve not just only for our cities, maybe for the future generations as well. So yeah, thanks again, once again, for your time and active participation. I look forward to collaborating with you in the future programs also. Thank you very much.
Thank you, sir. Thank you so much. Okay, just let's move on to the next session. Madhuri ma'am, are you here? Madhuri madam, are you there? Participants, please wait for a while. And just as she's checking whether she can able to share the screen and all. 1 minute, please. Yes. Uh, Okay, good evening once again. Our next session will focus on machine learning for waste volume prediction. We are honored to welcome Ms. Madhuri Penikalapatti, Senior Machine Learning Engineer at Visa, Bangalore. Ms. Madhuri has built her career with a strong foundation in big data engineering, data science, and machine learning applications. Prior to her current role at Visa, she worked at Knowledge Lens, where she contributed as a technology lead, senior big data engineer, and data scientist. She brings hands-on expertise in scalable ML solutions, predictive analytics, and applied AI for solving real-world problems. So her session will guide us through how machine learning models can be applied to predict waste volumes, helping cities and organizations plan better for collection, recycling, and resource management. We warmly welcome you, Ms. Madhuri Panikalapatti, and look forward to your insightful session. Welcome you, ma'am. Ma'am, kindly check your connections, whether you can able to talk. Ma'am, it's not audible.
Hello, can you hear me now?
Yes, ma'am. Now we can hear.
Okay, thank you. Sorry for the inconvenience.
It's okay, ma'am. No issues.
Yeah. Hi everyone, I am Madhuri and currently I'm working as senior ML engineer at Visa. Before going into session, I just wanted to thanks everyone for joining this session and thank you MITS College for giving me this opportunity. Before just going into session, I want to introduce the technologies that I have worked on. I have overall 7 years of experience. From beginning of my career, I was working on back-end engineering, data engineering, machine learning, generative AI, and agentic AI applications. So today I feel excited to present on waste volume prediction using machine learning. Let me share my screen. I am sharing my entire screen. So as the name suggests, we are trying to predict waste volume, like how much of waste will be generated in future, like in next 1 month or in next 2 months, how much of volume will be generated so that we can plan our infrastructure accordingly, so that municipalities can arrange that many collection vehicles, that many collection agents and all prayer. Instead of just right now, it's a traditional approach. System will react only if a event occurs. Suppose if some collection exceeds, some dustbins are overflowing, then only the system reacts. Our goal is to make this reactive system to proactive system. That's why we this is very important use case of machine learning. It it uses historic data to predict how the data in next 1 year look like. How much percentage of waste volume will be increased if population increases by 10%. And I think everyone will be much interested in this topic because even we are the stakeholders in this topic. We are stakeholders, like how it will be like waste will be generated even at our home, right? We will give waste to collection agent. And have you ever thought what happens to the waste that we generate at our home once it goes out of our home? It's not such an interesting topic, but what happens after this is the main problem that countries and nations are facing today because of the inefficiency in handling this waste. So our goal for today is to incorporate machine learning on the historic data to predict how much of waste will be generated in future, not just based on historic data, not just like based on current population. Suppose in next 10 years 10% of population may increase, our GDP also might increase. So based on all these fluctuating factors, we need to predict how much waste volume will be generated so that we can plan accordingly. We can move from reactive system to proactive system. Now let's see what is the cost of inefficient waste management. If we are inefficient in predicting how much waste will be generated, it will be a global resource strain. It will add extra strain on the department so that when an event occurs, when overflowing occurs, they have to arrange all the vehicles, they have to arrange people. It will be very difficult to arrange at that particular situation. Instead of, we can do efficiently by planning. And if we plan, we can take efficient collection routes. So there is no point in going to a dustbin which is empty, right? Instead of that, we can use that time to go to a dustbin which is already filled and overflowing. And it is like it will help us to move away from reactive crisis management. It will make us to move from reactive to proactive. So let's just assume that waste collection agent didn't come to your home for 5 to 7 days. What will happen? If they didn't come to your house, the waste will pile up in your house. Then it will overflow from the dustbin. Then it will give you some bad smells. Then it will attract mosquitoes and insects, right? Because of that, the environment will be unpleasant. And because of that, your health also will be damaged. Let's just assume that this happens at a street level or at a city level. what will happen? If waste management is not efficient, landfills will overflow, because if it overflow, it creates environmental pollution and air pollution. Because of that, the residents around that area will get health issues, and it will be, suppose if it is some tourist area, it will decrease the income of that area. So efficient planning is always very much important when we are dealing with this kind of waste management systems, because there are many unknown factors which can increase waste or which can decrease waste. Suppose if it is a holiday day, the waste will increase. Suppose if it's rainy season, waste will increase. So there are many fluctuating factors here. We have to consider all those factors, and if we can do waste management efficiently, that's a success. That's our goal for today. So if we do, if we plan ahead, and if we plan a good waste collection routes, it will reduce air pollution in two ways. One way is landfills will not overflow, so that air pollution will not happen. And one more indirect way is, if we plan efficiently, we can only go to dustbins which is overflowing, and we can avoid going to places which is not needed. So it will decrease number of collection routes. So it will decrease number of carbon gas emissions. In the other way also, it will reduce air pollution. Air pollution reduction is obviously leads to environmental protection. So by here, I want to set our problem statement clear. Our problem statement is, we want to move waste management from reactive to proactive, from fixed schedule to proactive schedules. So to do that, we have to take data-driven decisions. And our goal is to accurately predict how much of waste will be generated at a specific location or at a specific time, so that we can deploy services there in a effective way. And to solve this problem and to achieve our goal, we are choosing machine learning as our weapon. So if we take data-driven decisions, this is actually a predictive analysis. That means that waste has not been generated yet, but you are predicting that in future, at this point of time, if population increases by this much percent, waste will increase by 100 tons. Like this much percent of waste will be generated. That means the event has not occurred still now, and you are going to predict the future. This kind of things in machine learning, we call it as predictive analysis. To do this predictive analysis, we have to take data-driven decision. In traditional approach, it's just guessing work. Like tomorrow, just send the collection agents to this street, go and collect. Even if there is not much dustbins there, it's just a fixed schedule. It's just some guessing work. Instead of that guessing work, we have to take data-driven decisions so that we can optimize all operations efficiently. Until now, I was talking that machine learning is our weapon, right? So I just wanted to tell what is machine learning. As the name suggests, it's a machine that is trying to understand your data. It will understand all the patterns in the data, and it will help us to predict how the next data will look like. So it's a special branch in artificial intelligence stream, in which the computer, if you give them one input, computer, it will try to understand the underlying patterns in the data, and it will help us to predict next set of data. To do this, we need some data to train our model. If we train our model properly, we can predict next set of data easily. So there are some process to do this. There is some process. I'll explain that in our later discussion. So I am sure until by now you have some idea of what is machine learning. If any of you is having any doubts, please ping in chat. I can stop and take that doubts, and I can move forward. At any point of time, if you feel I am going fast or if I am going slow, please ping in chat. I'll take that feedback. Yeah. Until now, we have seen what is machine learning. Now In machine learning, there are two kinds of learning. One is supervised learning and one more is unsupervised learning. I'll tell you what is supervised learning and unsupervised learning in a much more easy way, which is, if suppose let's assume that you are a teacher and you have children, students, and you are trying to teach them how to identify fruits. So you give them a bunch of fruits and you'll show them picture, like you'll show a picture of apple and tell them that any fruit which is in red color, any fruit which is in red color, and if it is in circle shape, it is apple. Any fruit which is in circle color, and if it is in orange color, then it's orange. That means you are using some kind of labeled data to teach students that this is this. So they are learning from labeled data. That is known as supervised learning. In the same way, let's assume you are a teacher and you have students and you give them just fruits and you ask, they don't know what is fruit. So you ask them to just sort it. They will sort it based on their shape or color. Suppose if all fruits are in red color, they'll make it as one group. This is called clustering or classification, and it comes under unsupervised learning. So in supervised learning, if you ask student, you have shown them one pick of apple. Suppose if you show again a small apple, and even if you ask them, they'll tell that this is apple because they are already trained on that data. So this is difference between supervised learning and unsupervised learning. So until now, any doubts? Until now, if you have any doubts, I can stop and take it. If you don't have any doubts, I'll just move forward. I'll just wait some 15 seconds. Yeah. I don't see any doubts, so I am just moving ahead with the presentation. So a deeper dive into supervised learning. I have already explained what is supervised learning and unsupervised learning. So if you take our data comes under supervised learning because I am taking data, historic data, where waste volume is already there, and I am going to train my model on that existing data so that I can predict for tomorrow. That means the result for historic data is already there. It's like you are showing apple to student, right? In the same way, result is already there. That's why it comes under supervised learning. And we will we use this data to train our model so that it can predict the next set of data. Models, there are different kind of models. These models will try, you don't need to write any rule like if population goes beyond 1 lakh, this much tons of waste will be generated. We don't need to write any rules. It will only understand all the patterns if we give the data. Now I'll show you data. Just tell if it comes under supervised learning or unsupervised learning. This is data that I have got from Kaggle. Kaggle is a website where everyone gets a huge data set for their model learning. This is called water waste data. You can also search for water waste global data set Kaggle. You'll get this data. So here in data, it's already there. Which country, what is the GDP of that country, how much waste is being produced, and some other data. And we have how much waste is generated that time. So we have this column, right? That's why it comes under supervised learning. Now, to solve any kind of problem in machine learning, this is not specific to waste management. This is for every kind of problem that you are solving using machine learning. There will be 4 important steps, which is one is data collection, second is pre-processing, Third is model training. Fourth is prediction deployment. We will see what is which step is what, and we'll go in the details of everything. First is data collection. Suppose let's take our use case only. For predicting based volume generation, I need historic data. I need current data from IoT dustbins, from sensors. I will predict based on whether it is like whether it is rainy season or it is summer season or it is spring season. So for that I need weather data, and I will predict based on how much population is there in a particular region. For that I need demographic source. So we have to collect data from all possible source possible and keep it to ourselves. That's the first step. And second step is pre-processing. Right now we have data, right? And there is no good data. There will never be good data. Not in this use case. In any use case, there will, if you collect data from multiple sources, there is 99.9% chance that the data is not clean. So you have to clean data by yourself. Not clean in the sense there might be some duplicates in the data. There might be some missing columns in the data. There might be some wrong details in the data. So you have to identify and do it. I was showing one data set, right? So this is the data set that I have taken from Kaggle. You can see that many columns are empty. This means this is missing data. But to our ML models, we should never give missing data. We have to pre-process it and fill some data and give it to machine learning so that it will understand all the patterns behind data. Filling this, we cannot randomly fill with some strings like some names or anything. There is a process even for filling it. If it is a numerical value, what to fill it. If it is a string, what to fill it. There is a process. I will explain in detail. So that is pre-processing. Next is model training. There is no single model that works best for any kind of data. You have to, it's like try and error. You have to try with multiple models. You have to see which is predicting accurately, and then you have to select that model for your data. Once you have model, you have to deploy it like to AWS or Azure or GCP, and you can use this data. You can route data to Grafana for chart, for showing it in the visualization, or you can send it to some alert management system so that in future, like in next 1 month, 1 ton extra waste is generating, it will alert that specific people. Like it will give them alert saying in next 1 month, one more ton waste is going to generate. So please plan accordingly. Please deploy that many people. Please make collection routes efficient. So it will give alerts. For, for doing all this, we need predictive analysis. That is third step, which we are going to do. In today, I am not just going to explain this. I am going to give you a demo, like how model performs, how it will predict and all I will show. So in any kind of ML thing, first is you have to collect data from multiple sources. After collecting data, second step is processing. After processing, that means after filling null values with some data, or after removing duplicate value, you have to send it to model. Model will try to understand all the patterns, and that after that you will get output. This is so let's discuss about system design. In this application, first layer will be data ingestion layer. We call it data ingestion because we are collecting data from multiple sources and we are trying to ingest it to one place so that we can refer it easily. So for this, we can collect raw data streams from IoT sensor, weather APIs, demographic databases, and historic data that I have shown through some automated pipelines. Like every day I can't sit and I enter today temperature is 25 degrees. Today it is raining. I can't enter every day, right, by sitting. So we have to schedule some kind of pipelines. Those are called batch pipelines, so that we pull data as per schedule. Every day for every 1 hour get data. that is known as data ingestion layer. Next is pre-processing and transformation. This is equivalent to the step that I told in as pre-processing. After getting all the data, we will extract the data and then we will pre-process it. We will replace null values with the mean or median kind of values. And then we'll do feature engineering. I'll discuss about feature engineering in later stages, but just as a one-liner, I can tell feature engineering as like feature engineering is to derive one extra column from existing data. Suppose if I have one date today, 19th September, I can create one more column like is holiday. Is 19th September holiday? If it is holiday, fill yes. If it is not holiday, fill no. So we are trying to create one extra column from already existing column. This is known as feature engineering. We'll do all these steps in processing and transformation. And next is predictive model engine. This is where I'll send data to my ML models. And operational integration. This is integrating with the and like integrating it with Grafana or Power BI or with some alert management system. Once we have data, we can integrate with any kind of system. Let me just take a pause here. Do you have any doubts? Rajesh Kannan sir has pinged there are 4 main types of waste management and understanding them can help business develop effective waste management strategies. There are 4 types of waste management: landfill, incineration, recycling and composting. Yes. So if we predict waste, how much volume of waste will be generating, we can do all these kinds of waste management efficient. Let's say if I predict 1 ton extra waste in next upcoming 10 days, I can get, I can, I can stream my people to go to that landfill and evacuate it properly so that I can even use it for recycling and composting as well. Thank you, sir. And one more doubt is how to collect this type data, ma'am. Yeah, this is very interesting question. This points to first stage, which is data collection. Data collection will never be from the single source. We have to collect from multiple sources. Like I say that for real time, you have to collect data from sensors like IoT powered dustbins and all, like how much it is filled, how much, from what time it is filled, kind of things. For historic data, you can get historic data from any government websites or from any research papers. This historic data is very helpful if you want to train model. And weather services, there are many weather APIs which will tell you how weather is going to look like. And this demographic data we have to get from some government websites or some platforms like Kaggle has this demographic data as well. I hope this is clear. And there is one more doubt. To collect data, start by defining your objective and research questions, then choose approximate quantitative surveys, experiments, or qualitative methods. Create data collection instruments, select a sample if needed, and finally collect, store, analyze, and act on your findings. Ethical considerations like informed consent and data privacy are crucial throughout the process. Yes. Actually, this data collection is like a multiple, it's a parallel work actually. You can never get all the data. So you have to collect it from whichever source possible. Suppose if surveys are giving you that data, get it, make it sit in your database. Suppose if we are getting from any government websites, get and normalize it and make it sit in your database. Any website available. I normally, to collect any kind of data, I normally use Kaggle. Kaggle, I'll just pin here. Kaggle has wide variety of data sets, which is It is collected by using surveys and by using historic data. So for any kind of use case for training your model, you can get data from Kaggle. If you think Kaggle data is not efficient, you can use synthetic data generator. There is one concept in ML called synthetic data generator. It will generate data for you. I will explain if time permits at the end. And there is one more question. A typical machine learning workflow is a systematic process for building and deploying ML models involving problem definition, data collection, data pre-processing, and model selection, model training, model evaluation, and deployment. This structured process ensures that models are effective, reliable. Yes. So as we have seen, there are 4 steps: data collection and normalization, that means pre-processing, and model evaluation. In model evaluation only, many things will come. You have to not just take one model and use it. You have to take multiple model which fits for your data and then evaluate it. There are some metrics. It's there in my presentation. I will show that metrics. Based on that metrics, you can select the best model. Please set time. Sure, I'll explain the synthetic data at the end. Yeah. I am moving ahead with the next steps. So I have a working demo for it. For this, I have used for deploying models, you can use GCP and AWS services. For now, I have trained model in my local. But if you are productionizing it, if it's a production application, we have to use services like GCP and database solutions. We can use Firestore or Postgres. Actually, this is very interesting thing. I'll tell how to use database for any of the ML solutions. Suppose if you get time series data, that means for every 1 second, if you get data, you have to use time series database like Kairos. Suppose if you get structured data, that means if you know that your data will have 3 columns or 4 columns, if you know set of columns, then you have to use PostgreSQL. And if you don't know how much data will come, or if you don't know what columns will be there in data, and if columns differ, then you have to use NoSQL DBs like Mongo. And programming core. I am using Python for doing this, and a normal industry standard is also Python, because Python has many efficient libraries and many open source libraries and models to support this. And Python is very simple. It's like you write it in English. It's like English. There is no syntax like Java, and it is known for its simplicity, and many people know it. And many of the machine learning and generative AI applications in industry use Python, the core engine, ML and the data tools. Yeah, we'll be using ML. ML is a weapon. This weapon needs tools. Tools are the libraries of ML. So in my demo, I'll be using scikit-learn, TensorFlow, and PyTorch. These 3 are the ML libraries. Scikit-learn you'll normally use if it is a very simple regression. Suppose regression means, suppose if you have A and B. Suppose let's take this density. To calculate density, you need mass and volume, right? So in the same way, if one variable is dependent on 2 variables to predict the next set of continuous values, it's a very simple use case, right? So this is known as regression. In such a same simple use cases, we use scikit-learn. It's not just like it's not dependent on only 2 variables. Normally, I just to explain scikit-learn is useful when we have less variables. That's why we are using scikit-learn. And TensorFlow and PyTorch are some of the advanced libraries which we'll use in recurring neural networks. Suppose if our variable is dependent on some 100 other variables, I want to calculate waste volume prediction, right? But waste volume prediction is waste volume is not just an independent variable. You have to consider how much population will be there, what is the GDP of the population, what is the place, is it a tourist place or is it a residential place or is it a corporate area? And what is the weather? What is the behavior of the people there? How many like how much organic waste will be generated. So my waste volume is dependent on so many other variables. If something is this much complex, we use TensorFlow and PyTorch. I hope this is clear. And data processing frameworks. Data processing frameworks, we use mostly Pandas. Apache Spark we use if we are using Databricks as a provider. For in our local, we can use Pandas. We use Pandas because you will be at the end, you will be having all the data in your database or in your file like a CSV that I have showed. To do operations on a CSV or database, it's very complex and it's very costly. That's why, and even it takes time. Suppose if you want to drop duplicates from CSV without loading it to pandas, you have to iterate over every column and see how duplicates are. We have to store duplicates in a particular list and then match it and then delete it. But if you just load it to pandas, pandas has inbuilt methods like drop duplicates, fill NA, those kind of methods you can easily use. That's why we use pandas as the processing framework for the complex data sets. I hope until now it's clear. Next is for our waste volume prediction, from where we can collect data. This we have already covered through doubts, but I'll just cover it once again. We can collect from IoT sensor data, we can integrate weather data, or we can integrate demographics data from external data sources. For IoT sensor data, it's a small robust devices equipped with ultrasonic sensors and are strategically deployed within dustbins so that it can provide us the real-time accurate measurements of the fill levels. And weather data is a third party integration where we'll get what is the temperature, what is the precipitation, what is the humidity and all. And for external data sources, it's like how much of population is there, is it a holiday day, or any major public events are happening in that area. Because if some public event, some gathering happen, there will be obviously more waste, right? So these are different kinds of data sources that we can collect. For smart bins, I think it's already covered in a previous session also. Like we can equip smart bins with sensors so that it will send a real-time alerts like how much is filled, how much is empty, what is its location and all. So that based on this data, we can take decisions accordingly. Suppose if something is almost 90% fill and the schedule is actually for tomorrow, but right now only it's already 95% fill. That means we have to act accordingly. We have to send waste collection vehicle to that dustbin just to go and collect. Instead of depending on fixed schedule, we are here taking data driven decisions. Now the ingestion pipeline. Ingestion pipeline, we have to ingest data from different diverse data sources. We can aggregate data from multiple origins like from IoT sensors, from real-time weather APIs and all. So even for data ingestion, there are two kinds of data ingestion. One is real-time, one is batch ingestion. Real-time data will come from our sensor dustbins, and batch ingestion is like the historic data. Like if you get data through some files, you can ingest it at every 1 week or every 1 month. That kind of ingestion is called batch ingestion. For real time, we normally use Kafka in industry standard so that the data will not be lost. The same difference. Real time is the streaming. Batch means we'll schedule like for every 1 hour, run this so that data will be updated. Real time is like real time data will come to Kafka and you have to consume from Kafka. Next is data pre-processing. This is very important step in your model performance will depend on how you pre-process data. First is data cleaning, data transformation, and feature engineering. Let me just go into each thing clearly. Data cleaning. Data cleaning is like you will handle missing values. Suppose if you have 10 rows of student marks and each student, as far as one student marks is missing, that he didn't attend the exams. So if you give this same empty row to model, it will not work out because data is missing there, right? That's why you have to drop that empty row, drop and send it to model. This is one thing. Suppose if one student marks are there in two rows, that means it's a duplicate, right? You have to drop that duplicate and send it to model so that model will perform efficiently. So these kind of things are called data cleaning. Data transformation is nothing but, suppose you have models actually understand numerical values better. And in our Excel, it can be either a string or it can be either numeric, right? You can convert this string to numerical characters. Let's say I have one column like yes, where I am filling yes, no. Instead of this yes, no, I can introduce two more columns. Let's say student is present or absent. You are just filling present, absent. So model will not understand much on strings. So that this one column you can transform into two columns like is present, is absent. If a person is present, you can fill one in each present. If he is absent, you can fill one in is absent. That means we are transforming one column, one new categorical column to two numerical columns. These kind of things are called data transformation. And feature engineering, I have already explained. It's like you will be creating a new column from existing columns. Suppose I told you day, right? Day, like day, date will be there. You can easily decide whether it is a weekday or weekend or it is a holiday. That means introducing new columns based on existing columns is feature engineering. To handling messy data. Next step is handling messy data. Suppose in the same use case, student marks. Suppose by mistake, exam is for 100 marks. By mistake, if someone fills 200 in one column, do we need to take it? Ideally, no, right? Marks will never exceed 100, right? Because 100 is our cutoff. So this is called outlier. It is going to 200, but average is 100. It is going to 200. You have to discard this kind of data so that our model will perform efficiently. This is called outlier detection. Missing data. Suppose one student is present, but his marks is not there. What is the industry standard is, we'll consider his other marks and we'll do average for the subject so that we'll not have much deviation in the model. That is how we handle missing data. And data normalization is, suppose you kept exam for 1,000 marks. Calculating for 1,000, it's not needed, right? Even you can normalize to 100. You can just by 100, you can do for everyone. So that data will be in range of 1 to 100. You don't need to deal with the much bigger figures. This is known as data normalization. Feature engineering, the same example that I have told. Features are the individual measurable points or characteristics of a phenomenon. In waste management, these are the factors that influence waste column. Like whether if it is a holiday, more waste is predicted. If it is not a holiday, less waste is rejected. Suppose if we have column like this in our data, we can transform it to like this. Is it's a holiday? Yes or no? 1 or 2, 0 kind of thing. This is known as feature engineering. Choosing the right model. As I already told earlier, no model is fits one data. Like if you just take one model and if you apply that model, you can never be sure that this is the efficient model. That's why you have to try multiple models, some simple models, some advanced models, and you have to measure its accuracy and then take a decision. So choosing the right model is also very important to solve any of the use case using machine learning. Next, I am going to explain about models. Until now, if as this is much technical, until now, if you have any doubts, I can take this. Rajesh Kannan sir has pinged about data ingestion, like how data will come from multiple sources. And real-time data ingestion involves actively capturing, integrating, and processing data. Yes. And data pre-processing is data mining is a critical step for preparing raw real-world data into clean, organized data. Yeah. Model always expects clean data, so that if you have any missing data things, you have to always fill it. Data pre-processing involves cleaning, transforming, and structuring data. Yeah, this we have covered in our presentation. Which city, India city, use any study for implementing municipality? I heard that this kind of thing is implemented in Nagpur using machine learning. They are predicting waste volume and they are making that collection routes efficiently, both in Nagpur and Indore. I'm assuming until now it's clear. So next step is there is one doubt from Kanchala and Anchari. If you have any doubt, please ping in here. Yeah, I'll just go ahead with the presentation. I'll take doubts even after that. Yeah. So a closer look into models. Models are, we actually have 4 models. I have taken this data set from Kaggle and I have ran it through multiple models, not just these 4 models, but these are the 4 models which are performing good. Out of this, we'll see which model is the efficient model for our data. If I tell that this is the efficient model, it's not like it will fit all the other data. For my use case, for my data, this model is efficient. But if you are applying it to different data, you can try with different other models as well. I have tried with some 7 models, but out of that, I found these 4 as efficient models. And these 4, especially first 2 are the most important models. In any of the machine learning applications, 80% of machine learning applications will depend on these first 2 models. And any other new model is just like a variation of these models only. You change something and name it some other model kind of thing. So I'll explain all 4 models and I'll show our code as well so that it will be helpful. First is random forest. Random forest, as the name suggests, it will create multiple trees and it will take average of all the decisions. I will explain it in a real terms. Let's say you have waste data, waste volume prediction data, and you have some 10 experts in your team. You are giving my data is of 100 columns. Okay, and you are asking these 10 people to choose some data from these 100 columns. So they can choose multiple duplicate data, or they can choose any data on their own. 1 to 10, one can take, 20 to 30, one can take, or someone can take from 5 to 15. So each one will have different but little similar data. So each expert will apply his own rules because he has domain knowledge, right? He'll apply his own rules and for he'll come up with one result saying this much of waste will be generated. So 10 people will come up with their own result and this model will take average of 10 people results. That is random forest. Here expert is machine learning model because in a normal our traditional world, people with domain knowledge can do that, right? Can understand the data and they can tell how much data will be generated. In our case, it's model. Model will try to understand the data. It will try to understand the pattern and it will give you the result. So here we are dividing data and we are asking each tree to work on it and give a result. At the end, we are averaging it. And it's a parallel process. Every tree will work parallelly. It will not depend on previous person like that. This is random forest and XG boost. XG stands for extreme gradient boost. This is not similar to random forest, but the only one thing which is similar is like there will be experts. Let's assume that you have data and you have 10 experts, and each expert will go through all the data sequentially. Random forest will make it parallelly, but XG boost will make it sequentially. Each person will analyze the data and he will predict this will be the waste volume. So we already have waste volume calculated, right? We'll see how much his result is deviating. Suppose our original is 100 tons from the historic data. He is predicting 70 tons. That means there is 30 tons deviation. He is not predicting accurately. So next person will come. He will learn from the mistakes of first person. He will see why original result is 100, why first person has predicted 70. He'll see what are the mistakes he done, first person done. He will try to rectify that mistakes and he will understand patterns. And let's say he may bring it to 85. Next, one more person will come. One more person will also analyze all the data and he will next bring it to 90%. That means a team will try to learn from the previous persons and it will not run parallelly like random forest. It will run sequentially. I hope this random forest and the extreme XG boost is clear for everyone. Next is hist gradient boosting regressor. As I told, first two are important and many models are like variations of the first two models. This hist gradient boosting regressor is the variation of XG boost because in XG boost we have some like deficiencies like it will process sequentially. That means it will take more time and it will go through each and every data point. It will add to more processing time. So that's why one variation of XG boost is hist gradient boosting regressor. That is, suppose if some data is similar, suppose I have 5 rows for population less than 100 and GDP greater than 5, almost data looks similar. I don't need to process 5 rows, right? I can just make a bucket like this data is for population less than 100. This bucket is for population from in range of 100 to 150. It is in 150 to 200 million. So we will use unsupervised learning first. We will just categorize the data and then we'll take some data points from each bin and we will try to apply machine learning model on that data only. That is known as hist gradient boosting regressor. Extra trees regressor. This is actually a variation of random forest because in random forest we will take data like randomly, right? One person will take some data and all. But in extra trees regressor, we will just take data based on some condition like population greater than 100, you do it. Population in between 100 to 150, this tree will do it. 150 to 200, this tree will do it. That means we are just taking on some condition and we are trying to predict based on random forest will consider suppose if Z is dependent on A to Y, A, B, C, D, E, F, G until Y. So random forest will take everything into consideration. It will make its processing slow. That's why extra trees regressor will not take all the factors into consideration. It will just take randomly. For predicting one value, I'll take A to G. And predicting next value, I can take from B to Y. That it will randomly change the input values so that at the end it will give the result. At the end, if we average, sometimes it will match random forest. But we have done it in a very less time compared to random forest. So these are the 4 models. Any doubts in the models? I'll wait just 30 seconds. If anyone has doubt in the models, please ping, because models, yeah, you can use these models in any other machine learning use cases also. It's not just for waste learning. This is actually a good learning for anyone from ML or just starting ML, because I have tried to put the simplest of explanation so that even if beginners to ML also can understand the models. I think until now it's clear. I'll just try to reiterate these 4 algorithms once again. Random forest, we can call it wisdom of crowd. That means we are taking everyone's result and we are averaging it. That means we are taking all the crowd wisdom and we are averaging it. That's why it's famously known as wisdom of crowds approach. In XGBoost, we can call it as learning from mistakes. We are trying to learn from previous mistakes. So it's randomly, we call it as learning from mistakes algorithm. And next two are just variations of this only. Hist gradient is, instead of taking all data, we'll categorize the data first and we'll take some data from each category and we'll feed this to model. Extractive regressor is, instead of deciding on the data split, we will randomly do data split and we'll randomly consider some features and we'll try to predict the output. At the end, we'll take average of everything. That's extractive regressor. Training and validation. Suppose if we have historic data, you will train on some 75% of data and you will test on 25% of data to see how your model. So you will train on 75%. So that model will learn your understanding patterns and all. And you have some 25%. This 25% result you are not going to give to model. You are asking model, like, I have already given you 75% of data. Help me predict result for this 25%. As you know the result of this 25% already, you can see how much accurate the model is. That is training and validation. We validate it with some metrics, RMSE score, R square score, and the MA score. But before going into this, I'll show how data looks like. How a code will looks like. So I am as I already told earlier, I am trying to do it with Python. That's why I am printing Python, Pandas, NumPy and scikit-learn versions. This is the version which is running in my local. And this is the data set I am taking. I have already shown this data set. We are until first and second, we are just getting all tools ready so that we can go to war. Third is we are trying to load this data into a data frame so that we can do all data related operations efficiently. That's why I'm sending this data path. I'm using function of pandas called read CSV so that I'm loading it to a data frame and I'm printing what are the rows and what are the columns. These are the rows, region ID, country, income ID, and all is the rows. And I'm printing column names as well. This is just to see whether we are loading correct data or not. And after that, our target is to predict municipal solid waste generated per year in tons. For that, we don't need some information like country name because we already have region ID. ISO 3C, we don't know what is this column. And some other things like other information underscore. Some columns starting with other information underscore, like I'll show that columns to you. Other information for solid waste management, other information national agency. This will no way contribute to me to predict total waste generated. That's why I just want to drop that column from data so I can make my data look clean. This also comes under pre-processing. This first thing will come under extraction. Like I am extracting data in my data path to one pandas data frame. This I am dropping. I am dropping all the columns which looks like this. That's come under data cleaning. Now I am getting length of data model. If my data is very less, I am just printing a warning like very few rows. The split will be small, matrix will be unstable, but I have lot of data. I have around more than 100. That's why this error will never come. And here we are, I already told in my previous thing, right? There will be two types of column. One is categorical, one is numerical. Categorical, I told that machine learning will not be able to understand categorical features much. So we have, if possible, we can convert it to numerical features. In numerical features also, suppose if I have commas in between, it will come as string in Python, right? That's why I'm trying that convert that strings to numeric. Suppose if I have percentage, I am just trying to remove that percentage. This all comes under my data cleaning. Until now, any doubts in the data? Yeah. Until now, any doubts in the code? I'll wait for a minute. Meanwhile, let me just have water. Could not see any questions, so I'm just going ahead with the next code. I'm taking region ID and income ID as categorical feature, and all the remaining feature I'm trying to convert to numeric. And after doing this is just visualization. I am just checking how much how many points are there, how many things are not null. Like for columns where municipal solid waste is in between 0.0 to 0.5 tons, we have lot of data. This is just a chart. This is for showing distribution of total municipal solid waste per count. Until now, we didn't, we just did only data cleaning, that too only one step. We didn't deploy any model. We didn't predict any waste volume. And we are trying to train the model. So next is pre-processing. Pre-processing, as I told, if some of the numeric values are missing, I am trying to take median of that column. And I am trying to replace that empty with the median. And I'm trying to standardize it as well. Standardize it means I have already explained, like if we are keeping exam for 1,000 marks, we don't need to store that much big number in our data frame, right? We can just we can do by 100 for everyone and take a small number. That is known as standardizing. For numerical features, I am trying to replace empty values with the median, and I am trying to standardize the values. For categorical features, for missing things, I am trying to replace it with mode. Mode means high frequency thing. Suppose if one value comes multiple times, there is a possibility that even for the missing thing, that value will come, right? I am trying to do that. And one hot encoding. This is important thing, and I have already covered it. One hot encoding means you are trying to convert categorical things to numerical things. I already told it, if there is one column like status where a student is present or absent, instead of having that as string, we are converting it to two numerical strings, two numerical columns like is present, is absent. In the same way, we'll also do for the categorical features here. This is code to form the transformer like numeric and categorical transformer and to apply these rules, median and the most frequent rules. And after doing all this, I am taking 25% as test and remaining 0.75 as my data to train model. Now, if we do this, you have two different sets. One is train and one is test. Now, I have already told that we'll be using scikit-learn, NumPy, Pandas, and XGBoost. So I am importing all the imports that I need to do this modeling. First thing is I am defining all the models that I need. I need random forest. That's why I am importing it from scikit-learn. I need XGBoost regressor. That's why I am getting it from XGBoost thing. Hist gradient. Hist gradient is also from scikit-learn. Extract is regressor is also from scikit-learn. I am just getting it. And I am giving state as 42 for everyone. This is just a number, like you can give any number here. Next time also, if you give same error, it will try to do the same operation. This don't have much significance. Only you can just define like this, just the functions. And after that, you are trying to, this is one dictionary. You are trying to iterate and evaluate each model. Each model I am sending name and the model to my evaluate function. After sending it to evaluate function, it will first train on the this X train and Y train data, and it will try to predict on X test and Y test data. We are training in these two lines and we are predicting in this one line. Okay, and we are in this next 4 lines. We are trying to capture some metrics to calculate its efficiency. Now I will explain what is that metric. So these are the major model performance metrics, which is RMSE score, R square value, and MAE score. First, we'll talk about MAE score. MAE score is mean absolute error. Suppose if you have to you have trained on some 100 things and you are predicting the next thing, and you know the value of that next thing should be 100, but model predicted it as 105. That means there is 5 difference, right? And 105 minus 100, so that difference will become as MAE, mean absolute error. Next thing which we should know is RMSE, root mean square error. Suppose this is also same thing, but you are doing square of both things, so that if I do one big mistake, RMSE value will increase. Suppose at one row, it should be 100 tons, but I have predicted it as 1000 tons. So RMSE square is 100 square, 1000 square minus 100 square. RMSE value increases. If RMSE value is more, that means I did a very big mistake. And R square is how much your output is depending on input. Suppose my waste volume prediction is 89% if your value is 0.89, that means 89% it is depending on input. So if R square value is high, that means our input is properly read by model and it is able to consider all the metrics efficiently. So these are the three major performance metrics which we can use to measure any model. So here we already have inbuilt function in the libraries. We don't need to write much logic because if you use any models, they'll already have the metrics so that you can just import that and you can use that. So now I am measuring on my both test and train model, and I am trying to capture both these MSC, RMSC, MAE and R square things, and I am storing for which model these metrics are coming. So at the end, I am printing that. At the end, I am printing this. Let's see. So linear For linear regression, this is thing. For random forest, my RMSE square is this. For my XGBoost, I have this value. For history, so we have to take for which model RMSE is this less. For normal linear regression, it is 98,000 something. For random forest, it is 27,000. XGBoost, it is 33. East gradient is some 1,23,000. Extratis regressor is 39,000. That means random forest didn't do much big mistakes. That means we can conclude for our data at this point of time, random forest is the best model. I am just printing the same thing. Like, what is the best model here? I am printing best model, and I am also printing that model has taken which all into consideration. And at the end, I have, this random forest is the best model. Then we are getting what are the top 15 important features that random forest has taken into consideration. So to calculate waste volume prediction, random forest has taken population, GDP, special waste, e-waste tons per year, industrial waste, hazardous waste, construction waste, the region ID, how much recycling is happening, agriculture. So these are the top 15 columns that random forest has taken to predict next set of things. Now this is scenario analysis. I have told at the beginning, right? Our this waste volume prediction is not just for to predict for the next 1 month or next 15 days. This is to predict not just in the series of time, but what will happen if the GDP of the country increases, if population of the country increases. So this code is for that. I am creating scenarios to the model, and I am asking model, suppose if my population is increased by 10%, how much my waste will be increased? As model already knows the patterns, it will try to, how it will normally do is, it will try to create a new data set from the existing data set by increasing 10% population, and it will see how the data will look like, and it will give us that result. And I have did same for GDP also. If GDP increases by 20%, how data will increase? And at the end, I have created one simple thing. Like, I already have all the data. Now I will give only three important features. Like, three important things are population, GDP, and special waste, right? I will give only these three. The remaining values you can take mean, which is already there. Predict me how much municipal waste will be generated. So it has predicted, suppose if people is 10,000 and for GDP this is the value and this much of waste e-tons are produced, then your municipal solid waste will be this much. It will be 180 to 6.89. That means it is trying to predict based on my existing data. So this is code. I'll just stop here. Like if you have any doubt in code, we can go through that piece of code once again.
Participants' mic is enabled. If you have any questions, you can ask.
I am just going ahead with my remaining presentation as I didn't get any doubts. And right now we have the historic data and we have predicted how much waste will be generated, but it is in my code, right? Like normal people who don't know coding, they'll not be able to come and see the result in my terminal. That's why we need to give them a way so that they can see it clearly. Like we can give one chart which will say in this region this many tons is being produced, kind of thing, so that we can route all our results to any Power BI dashboard or Grafana dashboard so that they can see charts easily. Once we are done with all these things, this is very helpful. If we even we can draw based on this data, we can plan for efficient collection, waste collection. We can choose best routes for waste collection. And as we are already predicting how much of the waste will be generated, we can plan our infrastructure accordingly. Like I can plan some more collection vehicles. I can plan for 10% of extra people. So this predictive analysis is very important to plan daily operations also. And it will, if we predict properly, it will lead to optimized resource allocation. Suppose in one area, waste is not generating that much. You don't need to send waste collection agents to that area every day, right? So in a way, it is saving the time of person. It is leading us to optimized resource allocation. And if you are not sending that person to unnecessary place, you are reducing cost, right? And it leads to significant financial savings. So end-to-end summary is, first we'll collect data and then we'll pre-process data. And based on data that we have, we'll train ML model, and ML model will give us some predictions. Based on that, we can optimize the routes, and overall it will increase the efficiency and sustainable. It will make city sustainable. So in future, we can add this predictive maintenance for computer vision. Like if bin is filling on a high speed, we can send people to clean it, or we can use that data, or we can see how much of recycling waste is there in that bin. So we can include many other like robotics. Like in the last session, Purushottam has told that we can incorporate computer vision and robotics as well. So once we have this data, we can include all those kinds of future technologies. And I have added metrics like to show how the power of predictive maintenance. In traditional maintenance, as I told, it's a reactive approach, and it's resource waste and environmental impact. Means we will react only when an incident happen. But if we make predictive maintenance, we can change from reactive to proactive. So I have taken one use case from Barcelona. They have incorporated this. And for them, these are the figures, like 20 to 30% of logistic cost is reduced. 20 to 30% of collection frequency is reduced. The overall return on investment can be get in 12 to 24 months. That means how much ever money you are spending on creating this application, you can get it back in 12 to 24 months. This is from a real-time use case from Barcelona. And what are the effects? Like as I told, if bins are properly cleaned, carbon footprint can be reduced. Emission of greenhouse gases will be reduced. That reads in a reduced carbon footprint. Fewer collection trip. That means you can plan trips in a more data-driven way, so that you can reduce fuel consumption as well. This predictive maintenance leads to dynamic scheduling. It will reduce missing collections and it will enhance resource allocation. Key performance metrics for this application, if develop this, how much fuel is being saved, how much CO2 gas emissions are reduced, and what is the cost per ton, what is the return on investment as a financial metric. So these are the success stories. It is already deployed in Barcelona in Spain, in Nitra, and in Nagpur in India. In Nagpur in India, data is collected for geotagged waste collection fleets and bins. So that real-time data is from bins and it has historic data. So they are trying to combine both real-time and historic data to predict waste volume. Yeah, if we implement this, it will obviously reduce the cost. It will save money for the country and we'll be future ready. Like in future, if we are predicting like 50 tons of more waste, we can plan it today only. Like by 2026, my waste will be increased by 10%. So let's increase people also by 5%. So we can transform our city's future as well. Any QA doubts?
It's a time for conclusion. Kindly ask any questions if you have.
Yeah, I'm open for questions. If you have any questions, we can take it now. Or or I am on LinkedIn. If you have any doubts in my presentation, you can reach out to me on LinkedIn as well.
One participant asked, Sangeeta, how to add chatbot to geospatial maps? Likewise, I have texted in chat box.
Okay. Actually, this chatbot is a different topic. It will come under generative AI. Even further data can come from machine learning. Suppose if you have data and suppose we have created one chatbot which is linked to smart bins, we'll collect data and we'll see, suppose we have 3 or 4 dustbins. Dustbin A is filled by 50%, dustbin B is filled by 60%, C is filled by 70%. We have all the data. Now user like a waste collection agent will see, will ask like what is my next priority, where I have to go and collect dust. Then we have this data, right? We'll just see which is which percentage is higher and we'll give him that the smart dustbin geo code so that he can go to that particular dustbin and clear it.
Okay. Thank you, madam. Any other questions, please? Feedback link is already shared. Kindly scroll and check, please. And it's a time for concluding. On behalf of the organizing committee, I extend our heartfelt gratitude to Ms. Madhuri Penikalapati, Senior Machine Learning Engineer at Visa Bangalore, for delivering an excellent session on machine learning for waste volume prediction. Your talk provided us with a deep understanding of how machine learning models and the predictive analytics can support efficient waste collection and resource planning. The clarity with which you have explained the practical approaches, real-world applications, and future possibilities made the session highly engaging and impactful for all the participants. We truly appreciate your time and enlightening with us for your expertise. Thank you, madam. Thanks a lot for your wonderful session.
Thank you so much everyone for listening to my session and I hope it is helpful and I have made it in a more generic and easy way so that you can apply these learnings in any other use cases as well. If you have any doubts in the models which I have explained or if you need code, please reach out to me. I'll share all the details. And if you have any doubts on machine learning and models also, please reach out to me. I'll be really happy. And thank you so much for MITS College for giving me this opportunity.
Thank you, ma'am. Thank you so much. Have a
Thank
nice
you,
day.
everyone.
Hello, good evening, madam.
Good evening.
Madam, can you share the yesterday feedback link? I attended all the session, madam. But feedback link is not open, madam. Yesterday, it's not visible in
That one
my
already
log.
expired. Kindly, if you have any questions with the resource person, you can ask.
Okay, fine, madam. Is there is any issues not to get the certificate, madam? I didn't put the feedback for yesterday's session,
That
madam.
one tomorrow you have to attend the session. After that, you have assessment. After that, only you can think about the certificate, sir. Thanks a lot.
Okay,
Thank you.
okay. Thank you, madam.
And for the participants, tomorrow's session will start at 2 o'clock. After that, that means you have 3 sessions on tomorrow. And finally, you have an assessment. And after that, you have a validatory session. Thank you. Thank you so much.
Thank you, everyone.